Okay, so today we are going to study about analysis of redundant truss. What do you mean by redundant truss? Which is the truss which is statically indeterminate. Okay, it means the number of unknowns in the truss will be more than the number of equilibrium equations. Okay, so we have already studied about how to solve statically determinate truss already in engineering mechanics. By applying composition and resolution, we can solve statically determinate truss. However, here we are going to study about statically indeterminate truss. Okay, so I will take an example of statically indeterminate truss and we'll solve it. Okay, by using second theorem of Castigliano. Okay, so let's consider this is a statically indeterminate truss. Okay. So here an external load of W is applied and this is hinged. Okay, and this one is roller support. Okay, so and let's consider this one, this is O. Okay, due to the external loading system, let's consider the number of first let's find out if the truss is statically indeterminate or not. Okay, so the degree of external indeterminacy will be number of reaction minus number of equilibrium. So here number of reaction is 3, number of equilibrium reaction is also 3 minus 3 0. Now statical determinacy of degree internally, so this can be found out using the formula n plus r minus 2j. So n plus r minus 2, the number of member 1 2 3 4 5 6, number of reaction is 3 minus 2 into number of joints 1 2 3 4, 2 into 4, so 9 minus 8 equals to 1. So we are going to solve a truss which has degree of indeterminacy is equals to 1. Okay, it means there is one extra unknown. Okay, and we need to find out that redundant unknown by applying second theorem of Castigliano. Okay, so due to this loading condition, let's consider the member forces are, this one is S1, this one is S2, S3, S4, S5, and let's consider the redundant member is this one. Okay, and I am naming this as X. Okay, so instead of the member, if I remove the member and I can apply same member force instead of the member like this. So I can write this as same W is applied. Okay, and this is hinged and roller support. Okay, so I was supposed to remove this member, but I forgot to. So this will be like this. Okay, instead of the member force, here member force is X, so removing the member I can apply two equal and opposite forces here, which is X and X. Okay, so this one is again S1, S2, S3, S4 and S5. So these two systems are same. Okay, so now we need to find out this X force. So what I will do, I will try to divide this total system into two parts. So how? So this will be equals to two parts. Okay, in the first part, what I will do, I will remove the redundant force completely. Okay, like this. This is roller support and this is hinge. Okay, so I have removed this redundant member. Okay, and with the loading condition W. Okay, so if this can also be written as this plus another system will be there. Okay, like this. So there will be no external loading in this system. Okay, so only there will be the member forces X and X. Okay, now due to this external loading system, the member forces can be found out as this member is removed. Now this is a statically determinate structure, so we can easily find out the member forces by applying composition and resolution technique. Okay, so now let's consider this. Due to this loading condition, the member forces are P1, P2, P3, P4 and P5. Okay, now what I will do, I will only apply the redundant force here and remove the external loading system. Okay, now here due to this only X force, let's consider the member forces are P1 dash, P2 dash, P3 dash, P4 dash and P5 dash. Okay, so as the addition of these two structures will lead to this structure, so we can write this as S1, the member force here, is equals to P1 in member force in the first system plus member force in the second system, P1 plus P1 dash. Similarly S2 will be P2 plus P2 dash. Similarly all the member forces can be found out. Now we need to take common X from all the member forces. Okay, if I do that, so I can write this system as this. How? So what I will do, this can be written as like, okay, so this one is hinged and this one is the roller. Okay, so if I take common X, so X is taken common into, there will be a value. So if I take X common from here, so the remaining part is 1 here and the remaining part is 1 here. Okay, similarly if I take X into K, X into, let's say K1 is equals to P1 dash. So I am taking X common, so remaining term is K1, so member force here is K1. Similarly X into K2 will be equals to P2 dash. I am taking X common. Okay, so here it will be K2. Similarly if I take X common from all the member forces, K3, so this one is K4 and this one is K5. Okay, now due to application of this unit force 1 instead of the redundant member or unknown redundant, the member forces can be obtained as K1, K2, K3, K4 and K5. Okay, so now what happens to this S1? Now S1 is equals to P1 plus X into K1, isn't it? So instead of P1 dash I am writing X into K1. Similarly S2 will be P2 plus X into K2, so and it will go on. So we need to find out the member force due to external loading system by removing the redundant member. Then instead of the redundant member we will apply unit force and find out the member forces K1, K2 up to K5. Okay, after finding out those things we need to find out X. Okay, so then we can find out S1 and S2. Now how to find out X, we will go through that part. Now the total strain energy can be found out by applying the first theorem of Castigliano. What is the total strain energy? As in a truss all are axial members, the total strain energy can be found out, Wi is equals to summation of S1, which is the member force in the first member, S1 square into the length of the first member divided by 2 into area 1 into E. Okay, if E is constant then let's keep it as E only. Okay, similarly if it is S1, if we apply summation, then for all the members we can find out the strain energy stored. Okay, where L1 is the length of each member. Okay, so L1, L2, L3 will give lengths. Okay, A1, A2, A3 will be cross-sectional areas. Okay, so E is the modulus of elasticity. Okay, so now we can write this as summation of S1 we have already found out as P1 plus X into K1 square L1 divided by 2A1 into E. Okay, now this is equals to strain energy. We need to find out this unknown X. Okay, so we will apply the second theorem of Castigliano, which says the partial differential coefficient of the strain energy with respect to the force X is equals to 0. So this term differentiation with respect to the unknown X is equals to 0. So if I differentiate this term, this will come as how much? Summation will remain as summation x square. Differentiation is 2 into x, so 2 into p1 plus x into k1 into k1. This one is into, okay, this one is x into k1, which is the differentiation of this term, into L1 divided by 2a1 into e. Okay, so if we simplify this, we will get is equals to 0. So 2 got cancelled out. Okay, so this is coming pkl p1 k1 l1 p1 k1 l1 divided by a1e summation. Okay, plus x is unknown to us, x summation of k1, so it becomes k1 square into l1 divided by a1 into e is equals to 0. So if I find out x from this, so we'll get minus this term summation of p1 k1 l1 divided by a1e, okay, whole divided by summation of k1 square l1 divided by a1e. Okay, so by applying this, we can find out the value of the redundant member or the member force in the redundant member. Okay, so here only we need to find out is this P1, which is the member force after removing the redundant force, and K1 is the member force when we are applying a unit force instead of the redundant member. Okay, so if area A2 are constant, if area cross sectional area is constant for each member and modulus of elasticity is constant for each member, then this formula can be written as minus summation of p1 k1 l1 divided by summation of k1 square into l1. Okay, so so if a problem is given, first we have to find out all the member forces due to two conditions. One is removing the redundant force, another is by applying a unit force instead of the redundant member. Okay, so after finding out those things, we need to draw a table which will be easier for calculation. First one is member. Okay, first one is member, then p, then k, then length of the member, then a. Okay, then another term is pkl by a, and another term is k square l by a. Okay, so if I find out this, so first member is member 1, let's say, then is member 2, and goes on. For member 1, this one is p1, this one is k1 l1 a1, isn't it? This is p2 k2 l2 a2. Now multiplying or finding out this calculation, will get p1 k1 l1 divided by a1. This one is k1 square l1 divided by a1. We'll get p2 k2 l2 divided by a2. This one will be k2 square l2 divided by a2. Similarly, for whatever may be the number of members, we have to find out this. After finding out this, we have to find out the total. Okay, so this will be summation of pkl by a, and this will be summation of k square l by a. Okay, after finding out this, we have to find out the value of x by putting here, okay, or in this formula. After finding out x, what we will found, s is equals to p plus x into k. So this will be p1 plus x into k1. Similarly for each member s1, s2, we can get the values. Okay, so here one note is there, for in p1, in the last member which is the redundant member, okay, x member, so this will be 0 and this will be 1. Okay, so don't confuse while finding or doing the calculations. Okay, we'll solve one problem so which will be easy to understand. And this means what I was trying to tell is this pkly term will become 0 for the redundant member. However, this term will come. Okay, so make sure you are getting the pkly term is 0 for the redundant member. Okay,